Hey, it's Joel Walzman, CEO and Master Electrician of Jefferson Electric. I just spent $120 on my house for a generator inlet and mechanical interlock. Check this out. But why is my generator inlet inside? I'm going to tell you more about that. If you're a prosumer, you can do this job too. If you're an electrician, these jobs are flying at us more and more. Stick around to the end, couple hiccups, few surprises. Let's rock. So with these are commercial CT meter cabinets. If you haven't seen that video, check it out here. That was an epic 22.5-hour workday and all kinds of problems and gray hairs, but a ton of fun and a nice runner's high. So what we're gonna do is we're killing the load that's on that particular meter. That meter is identified as home out of the 3 meters. That's conduit number 3, which is identified over here as conduit number 3. So it's clearly ID'd up at the pole. At the top there at the transformer, it's a mechanical lug with a set screw. So they're able to back that set screw out, remove those conductors. They're gonna put on the PPE. They're gonna do it hot. For liability purposes, we cannot show you that. And so with the load off, they'll disconnect. We'll make the breaker swap to facilitate the generator connection. Once we're ready, we'll signal them. It's gonna be 10 minutes flat, I hope, and then they'll re-energize and we'll be back online. I'm stoked because right now I've got a 125 amp breaker that's being serviced by a 3/0 conductor. So I can use 3/0 copper conductor, so I can put that on 200 amp breaker. The limitation, the reason that was not the case was the old meter cabinet, which we've corrected. One of my next tasks and the upgrade of power to this home is gonna be a directional bore from that meter cabinet inside the house. It's gonna be a little tedious operation. It's gonna cost me about $4 grand. Not quite ready to pull the trigger on that today, but that's gonna upgrade that old conductor that's original to the home. It's a 1938 lead coated mineral something or other deteriorated jacket copper conductor. So I'm ready for that thing to go. But today, generator outlet. So it's showtime, boys. Hey, excuse me, but we're in my laundry room right now, and I'm sitting on the floor about to show you the tools and materials that we're gonna use for this basic installation. Hey, second to last tool I'm gonna use, first one I'll introduce, Weha torque screwdriver. That's gonna be my fit and finish on my electrical connections on both ends of the wire feeding this box. Here is a pair of dikes, that's diagonal crimping cutting pliers. I'm going to use those to clear the space. I've got some old Datacom that's got to go. I've got a standard screwdriver that I'm going to make the electrical connections with first before I do that fit and finish and torquing them down. I've got a pair of Milwaukee 6-in-1 cutter strippers. That's for stripping my wire, of course. This is my electrical tester, digital multimeter for verifying my voltages when I've made all my connections. Here's an impact driver for mounting my box, a bandsaw for further clearing my space. I've got some conduits to cut out of the way. And then on the materials side, we've got 10-3 non-metallic cable, perfect for a job like this. You'll notice there's 4 conductors. With NM, you count the coated conductors, and that bare copper ground is an extra. Okay, I chose this generator outlet and this mechanical interlock on Amazon. 1, so it would be easily accessible to you. 2, because it was properly priced. 3, because it was well represented with the technical specifications, dimensions, everything that you could ask for. The NEMA part numbers. Buying from Amazon as an electrician, typically the parts are available, but often they're very poorly described, so you don't know what you're getting. I loved how these sellers pulled it off. You also got a free drill bit and all the labels, as well as a couple zip ties for cable management. In addition, I'm gonna need 3/4 inch offset nipple for my installation, thread lock, and mounting screws. Let's actually gear up for the next step, which is AES is going to kill power, and we're going to have a replacement of the main breaker. Stick around for that, then we'll jump right into this job. The linemen are prepping themselves and we're prepping ourselves. This is going to be 10 minutes flat. It's these kind of things that when you're inexperienced and you've got the big dogs making the big bucks outside, and man, those guys can make twice as much, especially if they're traveling, working overtime. Those guys can make twice as much as electricians, no exaggeration. This is going to be 10 minutes flat, start to finish. So I've already pulled 4 of the 6 panel cover screws out. I'm just going to drop some little tidbits along the way. That's a blunt tip electrical panel screw. It's got a large number 2 square drive and flathead compatible head, but it's that blunt tip that's killer. If you don't have those in there, you'll get flagged by building inspectors and home inspectors all day long. All right, rock that panel cover carefully using your elbow to brace. Rock that out. This cabinet is in violation. I recognize that. It's encroaching on the working panel space, the working space of this electrical panel. Dagnabbit! It is what it is for today. So here's the scoop. Come on in here, take a look with me. I've got my crappy old conductors coming in real low right here. That's a lead coated 3 conductor with it's got another circuit in there, and I don't know where that's going, back to the carriage house. But at some point, when I've got my own span panel, I'm going to put in an ATS, that's an automatic transfer switch, or a manual transfer switch right here. That is could be the Tesla Gateway 2 or 6.0, whatever we're on at that point. And that's going to give my span panel full functionality. My generator outlet is going to go right next to my span panel, and it will end up connecting long term. Today, it's right here because it's a simple system without the full function. Long term, it's going to connect in my ATS, boom, which is going to be located there. So it's step by step, slowly taking shape, piece by piece. Rome wasn't built in a day. I'm going to take these conductors, I'm going to land them in my new main breaker, which is going right there. That's a 200 amp main. Nothing changes on my ground or my neutral. I'm going to clip on here. I've got AC voltage. I'm going to utilize this nice little tester support. I'll turn on my lights and we'll go right. I'm going to clip one to a ground. And it's going to be hard to get in there, you know. I'm going to see if I can clip my alligator in there. Oh, there it goes. Tester says the juice is out. Let me check with them. They actually beat me to it. I was going to turn off that main for him, but awesome. All right, back to work. Before I take anybody else's word for it, I wanted to confirm that communication piece is one step. That's out. That's out. I tested it first on a known live circuit, and now we are de-energized. So let's get this out of the way. You know what I'm really disappointed by? I can't find my socket set. It's just silly. Okay, we're getting the main lugs off. There it is. I'm going to keep those mechanical lugs, so this will be good for another job. Okay. A lot of times those things are over torqued and they're just a beast to open up. Ooh, that one, as you know, when a terminal screw shows evidence being stripped out, it's over torqued. The two go together. It's almost always the case. It may not be over torqued if the implement that was utilized was the improper implement. That's possible that it was just a sloppy, connection between tool and terminal. So that's How about that 2-pole 30 amp breaker T? I really don't want to manipulate these conductors much because their jacket it's like a mummy wrap. There's not a lot to it, and it's almost just as fragile and as old. It's literally just multiple wraps. All right. Okay, that's gonna land there. Before I cut anything, I'm gonna get my main breaker in. This is gonna land here. It'd be embarrassing to not have a compatible main breaker at this point, wouldn't it? Whew. A lot of coordination down the drain. That's our main breaker right here. This is a QO 200 amp main breaker. It came with the lugs. It's got our specifications right here. I'm gonna be torquing it down to 250 inch-pounds. It's rated for 4 gauge to 300 kc mil. Conductors, 22,000 amps. Interrupting current, 120 240 volts. Perfect, that's what we need. Here it goes. Make sure I get it in there just right so nothing inhibits a good high quality connection, and it definitely fit in there like a glove. But what I'm seeing is there's a gap that I don't like. There's a gap right there. So let's see where that's coming from, and I see it. It's coming from the mounting screw, which is in place right where it should be. Beautiful. Crazy, bro. All right, slide this sucker right back in there, and that time it's there. Yep, I see it. All right, I've got a nice flush connection on the electrical connections right there. You can see that one pretty well. One just like it over here. Spin that nut on and crank this baby down. My next step, once I get these linemen cleared out of here, is to open up all this equipment right here. We're leaving the copper plumbing that goes to the carriage house underground, leaving this electrical for now. Clean up all the datacom and get it out. All right, now that we have that landed, let's cut this conductor down. There it is. I like that tool right there. That's just gonna clean this up. I want that copper to be as nice and bright as it can be without leaving any kind of residual behind from the insulation. All right, we've got a lot of videos on the basics of this stuff. We're gonna wiggle it and tighten it and give it a nice little, man, look at that. I feel like I'm at the end of it, and then you just wiggle that conductor and those strands seat in there, and you can keep going. Now you loosen it up and just do it one more time. Give it a wiggle. Let's get a little bit more on there for now. Number 2. Guys, if you are doing the work of an electrician, unless you're in a highly repetitive, very simple procedure, I always recommend wearing a tool belt. That's the default approach. I think it's the best approach. And having said that, where did I put my knife? It's on the floor. That's where you put it there. You avoid bending over and stooping and doubling back to pick up the tools you left behind. Wear that tool belt. Put the tools in there religiously. It's an efficient way to conduct yourself. If you're a Jefferson Electric team member, don't read too much into it. Just wear your tool belt. Default position. All right, snug it, torque it, and we're throwing the juice back on. We're almost there. What I'm gonna do is I'm gonna leave this breaker in the off position. What you want is for them to make those connections on the pole while this equipment is in the de-energized state. And when you do that, it's a gift to the lineman. It's an important safety function, and that they're going to make that connection, and voltage will be present through the system, but there will be no current draw because the breakers are in the off position. If we have current draw on this, like a water heater, electric water heater, something that's just gonna kick right on, we're gonna get an arc, and you're gonna create an unsafe condition for them on the pole. You're gonna exacerbate. Now they're wearing PPE, they're in insulated buckets, like they're layers of protection, insulated tooling, layers and layers of insulation. But de-energized state is when you make the electrical connection. So let's button this down, pop out there, rocking and rolling. It was just a quick moment. Everything went pretty well for the most part. Back to Zen, here it goes, turn away. Okay, the work with AES is complete. The main breaker is in. Before I go demoing all this out, I'm gonna put the breaker panel cover on for safety, because these safety Karens are getting in my head. Okay, now that I've got my panel cover back on, as you can see, because it's on, let's go ripping the rest of this out. I'm just gonna start cutting and dicing. I mean, look at these terminal parts. Yeah, look at that. That's a work of art. I feel bad. There's some dude who just spent a majority of his life right here at this terminal block, and here I am ripping it out. It's gorgeous. And it's completely unused. The only structured wiring I have in this house right now is one, the fiber optic overhead to that corner of the home that's serving one Wi-Fi router broadcasting across the house. I'm gonna have one extender. Everything else in the home is wireless. I think at this point, there's gonna be some contention out there. At this point, wireless has won the day over structured wiring. Ethernet, there's just a few applications left for Ethernet, and I don't need any of it here, and this is none of that. So it's all coming out. It's all coming out. Man, these are like big 50 pair telephone cables. Cuts off over there. Let's see if we can get to it. These diagonal cutters are nice because that's actually a pretty big bundle to get your linemen's around. And so you can kind of nibble through it. There's not much resistance there. It goes back this direction. Man, this house has got so many electrical issues. So many. The code actually does say, you know this? The code says unused data and control cables, data and communications must be removed. That's a code requirement from the NEC. And so I'm gonna start doing my part to make this world a better place right here, right now. Of course, in the mood. Okay, there's one. Let's get this out of here. All right. There's a Datacom water pipe bond. All these caution labels. Careful, if this is removed, warning, call the utility company immediately. Well, this is now obsolete. Nothing is connected. Hey, before we go any further, it's important that I let you know that this video is brought to you by the generosity of our sponsor, SPAN. SPAN is a smart electrical panel allowing you to monitor, control, and automate all the electrical circuits in your home. If I've got my way, this panel will be a SPAN panel. And the reason I'm installing a generator outlet today is that SPAN is now generator compatible with both standby and portable generators, as well as automatic transfer switches and manual transfer switches. It's an elegant solution that will optimize the energy management of my home during an outage, particularly when I've got a very limited power source. Now, let's take the electrical panel cover off and get back to work. Now that we've got our main breaker in, I'm going to just test the location of our transfer gizmo, and that is going to go here. So that'll be like that. It'll hold that breaker in the off position. That's not quite right. That goes there. And then when we flip the breaker, it's going to come here. Yeah, that's it. All right, so that's where that's called the mechanical interlock. More expensive than it probably should be, but it does exactly what you need it to do. When that breaker goes to the off position, the base plate stays attached to the panel in the back. This drops down such that a mechanical interlock allows two opposing breakers, two power sources, to not both be on simultaneously. See what that's going to do? The generator breaker can now be thrown. However, the main breaker cannot be thrown until the generator breaker is off and the mechanical interlock. Okay, so that's the space we need. We're going to relocate our surge protector, relabel our super sketchy panel labels here. Let's do it. Off in a controlled fashion. Surge protector comes out. You know, before I do that, I need to rock it off the bus. It's a very low draw, but still, be kind to it. Rock it in over, connect my neutral over here before rocking it in. This is a Squared EQO panel. Their motto is world's finest, and they're pretty good. They're pretty good. They did have a massive recall. If you have a Squared E panel, I think from 2019 to 2021 sometime, it might be eligible for replacement through Squared E's recall program. That's a Square D QO, not Homeline, electrical panel. All right, time for the 2-pole 30 amp breaker. Check this out. I'm gonna leave a, did you see that, did you see that? I'm gonna leave a link to this in the description. I think this is a really nice kind of minimalistic way to proceed with 1000 volt rated screwdrivers. It's a Klein implement. Klein since 1857, or the dawn of time. Quite old. All right. So this is a NEMA 3R outdoor rated generator inlet. It's got a flip cover with insulating material to keep things out of. It's also got threads around the cover because some generator cords, after you plug them in and twist lock, you can actually screw in what would be like a strain relief to secure to that. So this is generally, I'm going to say 99% of the time, installed outdoors. However, in this case, I'm using a portable battery backup. I'm going to show you more about that in the next video. A generator can never be located indoors. That is a huge safety violation. Portable batteries, lithium batteries, no off-gassing, safe. In fact, better to be located indoors because batteries prefer to be treated like humans. That's right, climatized space, similar to a human being. If you're comfortable, the battery's comfortable. If I need to run a portable generator, I can. It's the same setup, but I'll have to pass the cord through the window and locate that outside. There are some huge advantages to not having your generator outside, where it could get stolen, rained on, become electrically energized through water, rainwater, puddles, things of that nature. So I'm really excited about being able to utilize a lithium battery system indoors. Take one of these knockouts here to locate and create a little bit of space. See, I want to use a knockout that's pretty close to my breaker so my wire length is minimal and I'm not congesting my panel. I like really any one of these. That one is pretty accessible for a 3/4 inch connection. So keep that beater screwdriver nearby. Proceed with caution. I'm going to use that right there. Onboard hammer, needle nose pliers. If you're a DIYer doing this project, I highly recommend that you de-energize the panel. And some would say anybody should have a de-energized panel. And that's not a terrible idea. All right, put the needle nose away. Those are more for light duty, and these lineman's pliers will hold up to really any abuse for years and years. Knockouts out. The offset nipple is really nice in that there are a lot of different kinds of attachments you could use here, but the offset nipple is going to allow me to accommodate the difference in spacing off the wall between the two pieces of electrical equipment. So it'll look good, be clean, and line up every time because of the versatility. So rubberized knockout. It's very interesting. Look at that. Beautiful. And it comes out in a 1/2 inch. Bust it out to the next size, which will be 3/4. Actually, the whole size is 1 1/8 inches. Ooh, it's pretty stout. Okay, so I learned this along the way, that this is actually only designed for 1/2 inch connections. And I'm gonna have to drill that out, even though it looks like a knockout. I was going at it pretty aggressively and bent the side of the case a little bit. So I'm using my step bit, 3/4 inch. I'm gonna go to low speed for the sake of the drill and the bit. Okay, just gonna rotate that step bit back a little bit more. There it is. We'll get our box mounted. Okay, upgraded to SDS with a 1/4 inch SDS plus bit. I can't take the other, right? In part because I think that's poured concrete with an exterior brick veneer. That's way more than I expected. Okay, if you had just been smarter than I and used a 1/2-inch nipple, that would have just been seamless. Absolutely 100% seamless. No drill out required. So again, real mistakes so that you can make real money. Model of our show. It's got a 1/4-inch air gap. Thanks to the, it's a little smaller than that. Thanks to the standoffs in the back of the box. That 1/4-inch air gap is required for equipment protected only by enamel, subject to rust in a moist environment. Now this looks actually pretty dry, but it could be moist because it's a exterior wall and masonry. Okay, put a level on that. Make sure you're tidy, in good shape. Lock nuts on both sides. Bushings, PVC bushings, not required in this circumstance, but if you're unsure, always a good idea to throw them in there. You gotta have your lock nuts though. PVC bushings alone are not acceptable to secure conduit and fittings. So, in the instance of a fault, electricity will actually flow through the enamel where it's scarred by the lock nut and the teeth on the lock nut, through the fitting, through the cabinet, and to the ground bus, which is common with the neutral and goes back to the XO on the transformer. So you want to have fittings tight. Now that should be instantaneous function and the breaker should clear and it should be literally a fraction of a second. But if something goes wrong, it could sit there and pop and arc and sizzle. And so I want all my fittings solid and tight. Now let's just put a level on that. Yeah, it's not perfect, but it's 32nd of an inch. Okay, that's fine. So now I've got my 10-3 non-metallic cable. I'm going to feed it this direction. So I'm working it away from the electrical panel. I'm going to be cautious because this bare conductor could arc against those breaker terminals right there, and I'm in contact with it. All right, my jacket, at least a 1/4 inch. I'm going to have my jacket intact there, at least a 1/4 inch into each box, and I'll strip and cut, terminate that panel side last. I'm going to go ahead and trim these down. See, I want to have some serviceability for future. I want to have a little bit of working length, but I don't need quite this much. I'm going to make my ground a little bit longer than the others. The terminals are well marked and the instructions are good. So let's get this baby terminated. I've got my torque screwdriver set to 35 inch-pounds as specified in the requirement. I've got my Magmaster holding my stuff here. Like I said, terminals are well labeled. W is white or neutral. Looks like it comes in the loosened open position. So we'll just snug that down. Oh, it's quite the little turn, 35 inch-pounds. I hope you ate your Wheaties. Oh, whew. All right, you always do the tug test. Man, that was down pretty tight. I wonder if I got in front of the plate. Let's try it again. Probably what happened was my wire got on the wrong side of the terminal plate. We'll call it user error, not device error. Okay, there it is. Ah, rock solid. Moving on. We've got to double check too when you're done, because all the manipulation of the device, particularly when you're using stranded conductors, can cause them to come free. So we'll get them all in there and then we'll do a double check on the tug test. If something's going to go wrong, it's going to go wrong here at the terminations. Okay guys, utilizing a $215 electrical, even if you're German, this is professional torque screwdriver set to 35 inch-pounds, just like the specifications. It's stripped out. The terminal's stripped out, and so I've got the plug taken apart here. It's the screw, not the plate. Thankfully, I'm pulling this termination out, and there it is. I've got the plate, I've got the screw, and look, it's stripped right there. Oh, it's frustrating. That's all too common. So you know, it could be the product. It could be it's worth paying another $15 for the Reliance product. That's a reputable brand, but I'm gonna have to replace that screw right there because that's my path of least resistance right now to get this installation complete today. So I take a little bit more liberties on my own house at times. Instead of replacing the whole product and waiting to complete this job at a later date, I have replaced the screw in the hot terminal for the black conductor. And it was a little bit of a pain finding the right one, but I landed on a 1032 hole forming ground screw, and it looks to be a pretty good fit. So there it goes. And I'm going to be a little bit more cautious. I'm going to under torque this just a little bit. I'm going to go with my electrician spidey sense on this one and not 35 inch-pounds. And there it is. Okay, I see. Okay, I've got to relocate the conductor to the other side of this same terminal. Minor adjustment, and that will allow the cover to fit on there. Plastic cap. So loosen up just a bit more. Wow, this is just, I don't usually get annoyed. I'm a little bit annoyed right now. I am. Okay, maintain the calm. Wow. Man, guys, this is just so not where I'd like to be this moment as far as representing professional DIY. So what are the lessons learned? It's be patient, have a stuff box at hand, don't buy the cheapest product. Know your tolerances. Be patient. You see, stripping out terminals it's too common in the electrical industry. If you're not working with highly reputable name brands like Hubbell, you know, you just get into some other stuff sometimes, and that was a little bit disappointing, particularly since we're using high quality tools and we're sure we're at 35 inch-pounds and that was the specification. But we've overcome. We've done a final tug test. Everything's snug and we're folding it into place. Fold those wires, don't cram. Make sure the ground does not come in contact with one of the hot conductors. That's why I folded it to the back of the box first. We're there and we're putting the screw in. It's time to strip back the NM cable. Still an energized panel, but a de-energized conductor. And probably should have stripped it before I put it in there, but there it goes. Okay. My conductor length. Grounds and neutrals will be here. And that's about all I need. So it's going to be pretty short. Let's cut it there. And we'll cut everything to length individually. Pull back the paper insulation. I typically go in the order of grounds, neutrals, hots. So I'm going to fill up this back ground bar first, because if you fill up the front ground bar, neutral bar, then you have trouble getting to the back terminals. So let's do that ground at the back. Bend it at right angles, too far. And that's here. It's real basic stuff here, but in terminating breakers, you always want to terminate a breaker in the off position. And like I said earlier, probably the whole electrical panel in the off position. These are not insulated gloves, electrically or thermally. So I'm at risk So terminate the breaker in the off position. Use the appropriate screwdriver blade, because if you don't, you'll strip the terminals, most likely. Don't compromise on that. This is a number 2 square or ECX. These breakers are rated for 2 conductors of the same size. And that's pretty cool. So I could legally and lawfully put 2 conductors under this as long as I do it in a proper manner. Check your breaker data sheet for more information. And then in addition to that, not over torquing or under torquing is important. This is a $38 breaker. Stripping that out is just disappointing. Breakers are, at some vendors, non-returnable. They will not take them back. 35 inch-pounds, boy, bro. I'm proceeding with caution. Been burned once today. I feel like I'm pretty close. I'm stopping. In fact, I'm gonna back off, and I'm gonna just know when I get to 30. There's 30. Okay, I like putting the extension in there. It gives me more reach. Keeps my hands out of the panel so I'm not rubbing my hands on the metal edge of the panel. There it is. Nothing stripped. Boom. Okay, that's good. And now let's check the instructions on the side to find our ratings for this wire size on ground and neutral terminals. Okay, so right now, because we don't have the mechanical interlock in place, main breaker and generator breaker are hot, so that I can just check a couple things. That's 127. Our line is running a little bit hot. Ooh. Okay, that's good. The reading I got 0 on. I like having that insulated sleeve to keep it off the others. 127, 254, so that's hot to hot. That's line 1 to line 2. 127. So back to this. Why did I get 0 on this reading here? And that's because that's neutral to ground. That's a functional 0, even if you get a couple stray induced volts. So that looks good. Now what I'm gonna do is just another thing here. I'm gonna do continuity check from neutral to the ground bar. That's as it should be. And I'm gonna go voltage here from one phase over here. Everything's matching up. Looking good. All right. Just check around and make sure you don't get anything funny like 54 or 78 or 102. Those would be strange readings that would require further investigation, but would typically not be the case. So what does a 2-pole 30 amp generator inlet and breaker power? Right now, that's hot. So I'm gonna shut it off, close it up. We know it's good. What is that power? Well, Ohm's law, right? 30 amps times 240 volts, which is what this is operating at, is 7,200 watts. 7,200 watts is going to typically be enough to power one whole house air conditioner, maybe a pool pump plus lights, a gas furnace, actually even 2 or 3 gas furnaces, or maybe more importantly, 1 refrigerator, 1 sump pump, 1 gas furnace, 1 TV, and a couple of LED lights. That's what that's gonna give you right there. So I'm gonna need to manage my loads during an outage to avoid overloading whatever power source I have plugged into here. It's gonna have overload protection, and that'll trip out when I exceed the rating of the equipment. That's where SPAN comes into play. I can do that from the cell phone, and I don't have to run down the basement steps to manage those loads. Monitor and manage through SPAN. Smart. It's important to note that right now, in that position, this is a suicide plug. Those are energized. It's absolutely unacceptable. You've got to install the mechanical interlocks. We're not done until this baby's in, and that is going to provide the safety that your muddled brain during an emergency outage needs in order to keep everybody here on this planet. All right, let's do it. All right, that's what we're looking for right there, folks. It's not real complicated. It's it lines up, hopefully, just like that. And it slides. That's a mechanical interlock for you. So let me take a little due diligence with my folding rule, because that's the type of small methodical, simple to use measurements and tools that electricians like to utilize. Look at that. Oh, I think it's actually quite intuitive and user-friendly, but we'll see if I get it right the first time. I like it. I like it a lot. Lines up in an intuitive manner. Let's mark our holes. We're over the trash can, of course. We're utilizing the supplied bit. It's very kind of them. Make this simple for us. Low speed, low to moderate force, and here we go. I'm gonna deburr the backside here a little bit. We'll see how this all fits. Before we put these screws through, let's get this thread lock prepped. Whoa, that was rich. And through it goes onto my glove. Okay, that's plenty. I will never get the threads off my glove again. Now I'm gonna get them on the carpet. Oh my goodness. That was easier than it looked. Now, let's just try that on for size. No shame. We're all friends here. All right. Oh, look at that. Not so bad. We flip that main. Drop this piece. I'm gonna have to do it once. Sorry, honey. There, drops into place. That turns on, and it's back. That's it. It works. Now that the safety measures are in place, our generator at Inlet is complete. We're going to show you next up the simplest, most elegant, out-of-the-box portable whole home battery solution on the market today that's up and running in minutes. So stick around and subscribe to Electric Pro Academy for real skills to make real money.